My presentation is about inspiring accessibility solutions from virtual reality experiences. When I talk about accessibility, I'm talking about access for people with disabilities. A lot of the things that exist inside of virtual reality technology do not work for people with disabilities. My purpose is to show you companies and projects that have done work to consider people with disabilities. I hope a lot of these examples become regular features in virtual reality. The first example will be Vacation Simulator, which is one of the most popular titles in the virtual reality store. It's made by Alchemy Labs, which was acquired by Google. The idea of the game is that it is set in 2060 when robots run the world. In the future, the robots will teach you what people used to do on vacation in our current world. The idea is that sometime in the future, people might not understand that humans used to work at a convenience store or humans used to go to the beach and play volleyball. The first feature we want to highlight is a solution that helps people who are deaf or hard of hearing have a better experience. It also helps people that speak a different language have a better experience because Vacation Simulator was recorded all of the audio in English. In the next video that I'm going to show you, you will see the Vacation Simulator VR app. I pull open a drawer labeled Subtitles and turn a dial to switch between available languages. English, German, Spanish, French, Korean, Chinese, or binary code. I set the language to Japanese. I put a card labeled Human 01 into a slot and pull a lever to start the vacation. In an elevator, a sign says, "Welcome to Vacation Island. It sure is a place." When the elevator door opens, there is a robot guide with subtitles that says, "Welcome to the grand opening of Vacation Island." Before you vacation, we should learn how to talk to bots. When you're close, just wave to get a bot's attention. Try it now. I wave, and the robot says, "Great job. You really nailed the standard human greeting protocol."
Welcome to the grand opening of Vacation Island. Before you vacation, we should learn how to talk to bots. When you're close, just wave to get a bot's attention. Try it now. Great job! You really nailed the standard human greeting protocol. Now for the fun part. Let's take a peek inside your suite.
From this video, we can see that they have added a captioning feature that is unique to virtual reality. There is an arrow indicator next to the captions to tell you which way you should turn your head to see who is speaking. In the screenshot, we have the text displayed in the caption and an arrow pointing upwards. The upwards arrow tells us we need to move our head upwards. When we turn our head upwards and are looking at the robot that is speaking, the arrow will now point directly to the robot that is speaking, making it easy to understand where the captions are coming from. This feature should be available in almost any virtual reality experience that uses 360-degree functionality. Unfortunately, most virtual reality experiences today do not have captions at all. First, I recommend we ensure all virtual reality experiences have captions. And then next, we need to encourage this feature that lets people know exactly who is speaking and where. Let's consider a solution for people that use wheelchairs. Many virtual reality experiences require you to need to stand up and reach for things that may be 2 or 3 meters from you. The requirement to have to stand up makes experiences impossible to play for people who use wheelchairs. Also, depending on a person's height, many virtual reality experiences may assume a certain height of a person and not work for people who are too tall or too short. Another problem is that if you are playing in a small apartment, for example in New York City or Tokyo, you often will not have enough space to reach for items that are far away, and you may end up knocking something over on the floor. We want to make sure that a VR experience does not require you to be standing up. I will now describe another video of an example of vacation simulator functionality. There's a split-screen video. On the left is a man wearing a VR headset and holding controllers. On the right is what the man sees inside his headset, a scene from the vacation simulator game in which he is on Vacation Mountain. His avatar stands on a stone path surrounded by deep snow. He teleports from the background to the foreground. Later, he is seated and appears to be shooting arrows from a bow. This is a great design achievement from Vacation Simulator. They redesigned the game so that it could be completed fully while seated. This means that people in wheelchairs can enjoy the entire experience. This also means that people that live in small apartments or who get tired from standing in virtual reality are able to complete the whole experience. Let me tell you another story about why it's important to be careful when playing experiences where you are standing and moving around. My dramatic example comes from my personal experience playing a game called Arizona Sunshine. The game is about shooting zombies and trying to survive many different levels. When you're wearing a headset, it's easy to become distracted and disoriented where you are standing or sitting in your environment. In your head, you may think you are facing your computer screen, but in the real world, you're actually facing the wall. In the game, I was shooting a zombie and making his head explode. However, in the real world, I felt my hand knock something on the ground. I took my headset off and thought, wow, that kind of looks like blood and gore. I knocked over a jar of salsa onto my wood floor. Oh my gosh. So I made a big mess, and this is something that's very easy to do, unfortunately, when we're playing virtual reality games. So we should strive and test virtual reality experiences to make sure they don't require big movements inside of the experience. And that way people can get that full enjoyment and be able to fully participate, and hopefully not make a mess on the ground. Let's now talk about a VR solution for people who are blind or low vision. A lot of virtual reality experiences make use of 360-degree video. This is content where, depending on the direction that you are looking, you will see different pieces of information. If you have Netflix today and you're watching a video on Netflix, you can turn on a feature called audio descriptions. And this is a feature for people who are blind or low vision to get auditory information about what's happening visually on the screen. A good example of this was the series Daredevil on Netflix, which is about a crime-fighting superhero who is blind. When that first came out, it did not have audio descriptions. So people who were blind were only listening to the audio of the video. They could only hear punching sounds or kicking sounds. This would not be enough information to know what was happening on the screen. Was the superhero punching the bad guy, or was the bad guy punching the superhero? An audio description would be like, Daredevil punches man in the face. Daredevil slides underneath a gate and does a cartwheel to land on top of a truck. So this solution works in 2 dimensions, but in 3 dimensions, we have 360 degrees to think about. My company, Equal Entry, has been doing work on the question, how do we provide audio descriptions for media that happens in 360 degrees? We showed you the example of the National Geographic experience with the sharks. So in this particular example, we have a scuba diver on screen, and there's text that says, turn around. Visually, the VR experience is telling you need to turn around to see some action. But if you're blind or low vision, how are you going to get that information? How are you going to know to need to turn to actually get an audio description of the important action? So our proposal was, let's start from a default view. This is where you would start inside of a 360-degree experience. And then we will add captions for the direction someone can be looking. This can be done manually. So here I'm showing a script where we actually defined what's happening above you, to the left of you, to the right of you, and below you. And then these descriptions can be provided to someone who is blind when we perform it live or when they're trying the experience live. There's currently not a way to record these in advance of someone trying out virtual reality technology. So we want to advocate that there should be a dedicated way to provide these descriptions in 360-degree media. For now, what our company is excited about is you can write a script and have that read out to someone live. So I'm going to show you an example of our user testing with two people who are blind and show you the differences in their experience.
On-screen text says, "Turn around." Near the sandy ocean floor, a diver glances at a nurse shark and stares back at you. Something white and fleshy slams into you from above, knocking you flat onto the sandy floor. The diver quickly swims to you as bubbles rise all around. Jackfish and nurse sharks swim by from left to right.
On-screen text says, "Turn around." A hammerhead shark swims slowly along the bottom, slowly coming towards you. It bites you in the face.
Oh my god! Oh my god!
Underwater cameraman swims over to check on you. A second diver picks you up.
Oh no! I like my face.
Now we will talk about a game called Beat Saber. Beat Saber is currently the #1 selling game for virtual reality experiences. And so, fortunately, it is also one of the games with the most accessibility support and considerations for people with disabilities. So in this example, the game actually is showing on the screen. There's a man holding two things that look like sabers or swords, but actually map to the hand controllers that you hold. And these blocks come towards you, and you want to smash the blocks at a certain rhythm. So the game by default was using red and green. Red and green is difficult for people with color blindness to see. In fact, in America, up to 8% of males in America are colorblind. So there's a feature that you can turn on in Beat Saber called color blindness mode. And this will change the colors of red and green to instead be blue and yellow. So we can see here the colors are coming through, and the point of the game is to be on rhythm and smash those blocks. So if you can't actually see which color's which, you're going to be confused and maybe hit the wrong block. So it's kind of essential that this game makes sure that all of its colors work for people who are colorblind. Another awesome integration for this technology is something called sub-pack vibration. So the sub-pack is a backpack that you wear on your back, and it causes vibrations on certain rhythms. So the way this works with the Beat Saber game is on the different beats when you're supposed to be chopping the block, you will feel a vibration either on your chest or on your back. And so this is an exciting project of working with people who are deaf and hard of hearing to have them try out Beat Saber.
How do you feel VR with Santa? Oh wow, amazing. Feel like you're in a different world, fantasy world.
Ask him, does he think he will get better the more he plays?
Do you think you will become better the more you play? Yes, definitely. The more I play, the more I get better. Play the game.
So this is the second time that Troy's tried Beat Saber. Troy, what did you think of Beat Saber?
Wow, absolutely amazing. As a deaf person, using the sub pack and the VR, I just felt in a virtual reality world that I've never experienced before.
This is Matthew's first ever try.
Fucking insane, bro. Downwards.
Yeah, good, perfect.
Right, what did you think of Beat Saber?
This game is wicked, 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 wicked. It's out of this world experience.
So you can see the joy there. And again, I think this is just exciting to see that this mainstream game can be made, playable and available for everyone. A lot of people might say, why would a deaf person want to play a game about music? And this shows you, people can feel the rhythm, people can get into the experience, and these people had a great experience. So I think this is exciting technology, and the world of haptics in general, the ability to feel touch and vibration and use that in virtual reality experiences is going to be very exciting for the future. Now I'm going to switch to another example. This is another very famous game in virtual reality. It's called Half-Life: Alyx. And this game, the example that I'm going to highlight for accessibility is the ability to play the game using a single hand. So as I mentioned, a lot of games make the assumption that people will have two hands and that they can operate two controllers. That's not always going to be the case. Someone could have carpal tunnel syndrome. Someone could have only one hand. So what I'm going to demonstrate in this example is a scenario where you need to lift a barrel inside of the game. And I'm going to show you a menu that they've added into the game where you can go from needing to use two hands to using one hand. So this is me inside of the experience. I have two hands, and I'm walking over to this barrel. Use both hands, pick it up, and put it down. Throw it against the wall. Now I can go to this options menu with one hand, this accessibility single controller, and I can turn on this mode called single controller. And so now an action in the game that used to require two hands can be completed just with a single controller or just with one hand. So here I just pick the barrel up now with one hand and move that to the side. So this is a huge area of virtual reality to explore. And again, we want to kind of encourage as a general rule not to require someone to have any type of specific dexterity or use of their hands, feet. We want to have as many solutions as possible to let people play virtual reality or use virtual reality. I'm going to show you now, this is a cool controller called the 3D Rudder. And basically this controller lets you do everything that you were doing with your hands with your feet. So this is obviously a very exciting potential device for people that have use of no hands but have full use of their feet. Let's look at a demonstration. this example, which is not a virtual reality game, but it is a game on the PlayStation and on the Xbox that actually illustrates so many accessibility best practices that I would love to see in virtual reality. And I want to show you this person's reaction to all the accessibility features that are in the game.
I don't even know how much. This is what we've been, with myself and other people in the accessibility community, this is what we've been advocating for so long. There's so much here. This is why I work so hard to promote accessibility. This is why, because this is important.
So that man who's blind and has been waiting so long to be able to play, this quality level game, he's having this reaction because this game actually has over 60 different accessibility settings for it. And some of the most impressive and exciting accessibility settings are ones that relate to being able to actually complete the game totally blind. They've created sound-based notifications to know where different objects and experiences are in the game. They have the captions. They have the ability to remap controllers. So a lot of the different features that I showed you in today's examples of great accessibility implementations, they've put into this experience. So right now I'm really holding up this game, Last of Us 2, as one of the best implementations for us to learn from and to be looking for in virtual reality experiences in the future. Now we will talk about supporting text alternatives, and we're going to use an example from Second Life. Second Life is an old virtual reality application built by a company called Linden Labs. I like to use Second Life as a historical example to show that there has been quite a bit of accessibility research and work inside of virtual reality, and we should learn from research and from success stories from the past. So one thing I love in Second Life is they have created the ability to add text alternatives to objects. So on the screen we have, it's a bit blurry, but basically everything inside of a virtual world in Second Life, you can right click and add a name or title and a description. So very similar to alt text and long description on the web, we can do the same thing inside of Second Life with virtual objects. So we also have some of the same problems that we see on the web, unfortunately. So this object, I'm showing a screenshot from Second Life. We can see the name has been set to SM-Deluxe Dinner Buffet V2 bracket mesh close bracket and then no description. So this is sort of like when we have the file name in our alt text on a web page. It's not good enough to properly describe the object to someone that can't see the object. So this is showing a close-up view of part of the virtual objects that exist in this Second Life world, and basically showing that we do have the ability, or we could have the ability, to set very specific descriptions for each object on that table. So I could set individually bread, plates, and asparagus, and I might want to do that if it's very important to understand that those three different objects exist. We might also want to know that cucumbers are on the table. Again, just like on the web, alt text can be contextual in virtual reality. Maybe all we need to know is that there is a table of food inside of the space. So I personally err on the side that I want to be able to give text descriptions for every single small object in the virtual world, and then work with developers on coding solutions and ways to interrogate that information for people who are blind and low vision. So I'm always going to be on the side of giving more information than less information. Another cool use case of using text alternatives in virtual reality is you can label, here we show we're setting the name property to this particular area of the world to Bahia Tiki, Honolulu Tiki Bar. So oftentimes in virtual reality, just like in the real world, we might tell our friends, hey, come meet me over at this location. So in Second Life, if I told my friend, please come meet me at Bahia Tiki, or at the Tiki Lounge, if there's no label for that object, a person who's blind and low vision wouldn't be able to come meet me. So again, this shows that if we set a proper name for the object in the world, then we enable the ability for people with disabilities to come fully participate and meet us in the world. And this was actually something super cool in Second Life. They actually built AI, artificial intelligence based tools for the avatars. So on the screen I'm showing that avatars could have a white cane with a red tip, or they could have a guide dog, such as a German Shepherd. And so the cane or the German Shepherd dog could be used to navigate in the virtual world. So maybe I'm unable to see visually the Bahia Tiki Lounge, but with code, I can look for all the objects that exist in the world and see that there is an object labeled Bahia Tiki. Once I have that set, I can use my guide dog or guide cane with additional code attached to move my avatar over to that position in the virtual world. And so this is something that already worked in Second Life, which does not currently work in 2020 in any modern virtual reality environment for socializing. So I really like to emphasize we should learn from the past and learn how they made the solution and make it work in today's virtual reality experiences. Another example I have is about communicating with developers who build virtual reality experiences. So on the screen, I'm showing a game called Audio Shield, where you hold two shields and you try to, again, to the rhythm of music, use the red shield or the blue shield to stop these balls from hitting the screen. For me personally, I felt that it was difficult to play this experience for a long time because there's quite a lot of visual action going on and it would tire my eyes. So this is showing that I was able to email the developer of this experience and I said, hey, I wanted to request when the product gets updated to have a dark theme or some type of less bright color option. That would let me be able to play longer. And I want to highlight here that Dylan Fitterer, the developer of this experience, he wrote me back quite quickly and said, sure thing, here's a modified stage dive skin file that removes almost everything and uses a black background. So basically this shows that if we do communicate with developers and let them know about accessibility requirements in virtual reality, we might be surprised by their willingness and interest to make sure that their experience works for people. So I was very happy with Dylan, and I was able to implement his functionality. And here you can see on the left-hand side the more busy theme, and then on the right-hand side a more minimal theme where I just have a black background and the orbs. So just highlighting that to remind all of us that if you start working with virtual reality and you find issues that exist for people with disabilities, you should communicate that with the developer or the publisher of that experience, because oftentimes the only way they know to go and make a fix is if they hear from people like us. I also want to show that there was a world inside of Second Life called the Virtual Ability Orientation Path, and it's a virtual ability world. And I love this world because it teaches you how to have an accessible experience inside of Second Life. So on the screen I'm showing three placards. One placard says assistive tech and explains what assistive technology is. The second placard says enlarge the text, and it teaches you in Second Life how to make your text larger on the screen. Similarly, the third placard says enlarge your view, which also teaches you how to increase your view in Second Life. So I think our current technology in 2020 can learn from Second Life that if you build accessibility solutions for people with disabilities, you should always document it and also teach people how to use it. So this world still exists in Second Life. It was probably built over 10 years ago, but you can go in and try this experience, and I encourage you to try it in Second Life, and then we should be requesting this in current virtual reality experiences to build tutorials and build help information to teach people how to get accessible experiences in virtual reality. This is showing the difference from the previous screen, that when I enlarge the text, I can actually choose the font size and I can choose the colors that are used to display text inside of Second Life. So I have a lot of customization options available in Second Life. The last topic I want to talk about is user interface components. So I know a lot of people on the meeting today are familiar with the web, and you may be familiar with this idea of web components or web user interface controls. So examples of these would be sliders, combo boxes, tree views. These are three examples of user interface controls. And we have built a solution on the web called ARIA, Accessible Rich Internet Applications, that helps make those controls accessible to people with disabilities. Well, I'm pointing out that we have the same issue in virtual reality. Basically, in virtual reality, you still have a lot of the same user interface components that you have on the web. So you might have sliders, you might have text controls, you have button controls. All of these controls can be shown also inside of 3 dimensions to get feedback from the user. And so we need to have something like ARIA to exist in virtual reality to make those experiences accessible to people with disabilities. So I'm showing you an A-frame GUI component that was built by Roland Dubois. So A-frame is a WebVR solution, and WebVR is basically the set of VR technologies that can be displayed and rendered in a web browser. So this example is showing I have buttons, labels, radio buttons, sliders. Roland was able to build all of those inside of virtual reality experiences, but unfortunately right now there's not a defined way to make those accessible. So we want to change that going forward. So how would we do this? One way to make this more accessible in the future is to participate in the W3C. So one area where you can participate is the immersive web platform. So there is an API called the WebXR Device API, and this is a W3C working draft. And this is where all the information for making virtual reality experiences work on the web is being discussed and worked through. Also, you can contribute to sort of the future of the idea of the Web Content Accessibility Guidelines for XR. So Josh O'Connor is one of the heads of the XR Accessibility User Needs group in the W3C. And they are building a set of requirements that will probably remind you of the Web Content Accessibility Guidelines if you're familiar with them. But these guidelines are going to be totally different in the sense that they need to be specified and applied directly to XR experiences. So both VR, AR, MR experiences, we need to gather together all the requirements and help developers and product managers learn what they need to do to make sure that it works for people with disabilities. I also wanted to let you know that currently on the web today, you can actually load 3D web content into a web page using a component called Model Viewer. So I learned about this technology from Chris Joel at Google, and on the screen I'm showing an astronaut 3D image. So to show that astronaut 3D image, we use a file format called GLTF. And so Chris said GLTF is the JPEG of 3D. So if you're familiar with audio files, a popular format is MP3. For video files, it would be H.264, usually an MP4 file. And for images, we have JPEGs. So this is introducing you to the term for virtual reality, that a lot of the objects we use in virtual reality are packaged into this file format called GLTF. So GLTF can also be compiled into a binary form, which is a GLB file. And this is showing, at least right now on the web, we do actually have alt text available for this new file format. So if I embed a 3D model into my web page, I can set an alternative text that's available to a screen reader. Now obviously we need to go farther than this, but I wanted to show you this today so that as web engineers or web developers or web program managers, if you encounter this new file format, you do know that there is at least a minimal solution that you can start using today. I currently use Mozilla Hubs for social VR. So Mozilla Hubs is a web-based social interaction platform. So much earlier in the presentation, I talked to you about AltSpace VR. That platform requires either a desktop application or a virtual reality headset to run. But what I like about Mozilla Hubs is you can have meetings with people via the browser. So you can basically, if you have a headset, have a 3D experience, but with Mozilla Hubs, you can also participate in meetings using your web browser as a 2D experience. If you'd like to learn more about this, I encourage you to check out my meetup. It's called A11Y VR, and that is located on the meetup page, meetup.com. We meet monthly, and we typically meet in the morning time of Japan. And so that means that it'll be the evening or afternoon in the United States. And we usually have 10 to 30 people joining our meetings. So if you would like to learn more and participate in my meetup, I invite you to come. We'll be sharing the links to this meetup in the materials that follow this presentation. If you would like to participate more, there's a lot of different ways you can get involved in XR accessibility. Just to highlight xraccess.org, this is a group currently building standards for virtual, augmented, and mixed reality solutions for people with disabilities. There's the W3C groups I mentioned. There's the XR Association. There's XRSI Cyber XR Coalition. There's the XR Collaboration Group. And there's the Educators in VR group. So I'll provide links to all of these, but depending on your interest, you might want to join up in one of these groups and participate in the discussions and help shape the future of accessibility for these new technologies. I want to end by saying thank you, arigatou gozaimasu, for listening to my presentation today. Again, I'm Thomas Logan. I'm the owner of Equal Entry. I manage 2 meetup groups, A11Y NYC and A11Y VR, and you can find me on Twitter at TechThomas. And with that, I'd like to now hand it back over to Makoto and move into the questions and answers phase of our presentation. Thank you very much.